Imagine you're standing outside on a clear night. No city lights, no clouds, just you and the sky. You tilt your head back, and above you, billions of stars stretch out in every direction. It's beautiful. It's overwhelming. And somewhere in that sea of light is a star so close it's practically touching us. And orbiting that star, a world, a planet. That might have conditions right for life. It's called Proxima Centauri b. It's our closest known neighbor beyond our solar system. And today, we're going to do something wild. We're going to figure out what it would actually take to go there. It's almost impossible. But almost isn't the same as never. Our solar system sits inside a little corner of the Milky Way galaxy. And like any neighborhood, we have neighbors. The nearest star system to us is called Alpha Centauri. It's actually a 3-star system. 2 stars, Alpha Centauri A and B, orbit each other. And then there's a third, smaller, dimmer companion star orbiting much further out. That third star? That's Proxima Centauri. And Proxima holds a record. Of the hundreds of billions of stars in our galaxy, Proxima is the closest one to our Sun. It sits just 4.24 light-years away. Now, 4.24 light-years sounds close. It has the word 4 in it. You drive 4 miles to get groceries. 4 doesn't sound intimidating. But let's talk about what a light-year actually is. Light travels at about 300,000 kilometers per second. In 1 second, it crosses the distance between New York and Los Angeles. Roughly 34 times over. In 1 year, moving at that insane speed without stopping, light travels about 9.5 trillion kilometers. And Proxima Centauri is 4.24 of those years away. That is approximately 40 trillion kilometers from where you're sitting right now. Our fastest spacecraft ever, the Voyager 1 probe, launched in 1977 and currently our most distant human-made object, is traveling at about 17 kilometers per second. At that speed, to reach Proxima Centauri, it would take over 70,000 years, so not close. But in cosmic terms, in a galaxy that's 100,000 light-years across, Proxima is our next-door neighbor, the friend who lives on the same block. And in 2016, astronomers discovered something that changed everything. In 2016, scientists announced they had found a planet orbiting Proxima Centauri. They called it Proxima Centauri b, or just Proxima b for short. They found it using a clever method. When a planet orbits a star, its gravity tugs on the star slightly, causing it to wobble. Astronomers measure that wobble in the starlight and work backward to figure out the planet's size and distance from its sun. What they found was remarkable. Proxima b is estimated to be at least 1.17 times the mass of Earth, making it what scientists call a super-Earth or potentially a rocky terrestrial world much like our own. More importantly, it orbits inside what's called the habitable zone, the Goldilocks region around a star where temperatures could allow liquid water to exist on a planet's surface. Liquid water, the ingredient, the baseline requirement for life as we know it. Now, Proxima b's year 1 full orbit around its star is just 11.2 Earth days. That sounds extreme. But Proxima Centauri is a red dwarf star, much smaller and cooler than our Sun, so its habitable zone sits much closer in. Despite orbiting so tightly, Proxima b could receive the right amount of energy. In theory, because here's where things get complicated, Proxima b might be in the habitable zone. But that doesn't mean it's actually habitable. Proxima Centauri, like most red dwarf stars, is a violent, moody little star. It regularly unleashes enormous solar flares, bursts of radiation and high-energy particles that would blast the surface of any nearby planet. Here's the problem. Proxima b is so close to its star that these flares aren't a minor inconvenience. They could be catastrophic. Without a strong magnetic field and a thick atmosphere to shield it, those flares could strip away the planet's atmosphere entirely, leaving behind a bare, irradiated rock. Does Proxima b have a strong magnetic field? We don't know. Does it have an atmosphere at all? We don't know that either. Then there's another issue, tidal locking. Because Proxima b orbits so close to its star, the star's gravity likely keeps one side of the planet in permanent daylight and the other in permanent night. Imagine a world where the sun never moves. One hemisphere is scorching, the other is frozen in eternal darkness. This sounds nightmarish, but some scientists argue it might not rule out life. At the boundary between light and dark, the terminator zone, temperatures could be moderate. Winds could circulate heat. And life, as we know, finds a way into almost every extreme environment on Earth. The truth is, we just don't know enough yet, and the only way to know more, we have to go. So, what would a mission to Proxima Centauri B actually look like? First, let's acknowledge the obvious. No currently existing spacecraft could do this in any human-relevant timeframe. Voyager-style technology gives us 70,000 years. Even if we tripled our current speed, we're still talking tens of thousands of years. We need a completely different approach. And actually, some of the world's smartest people are working on one. In 2016, the same year Proxima B was discovered, a project called Breakthrough Starshot was announced, backed by physicist Stephen Hawking and billionaire Yuri Milner. The idea? Forget big heavy spacecraft. Send tiny ones instead. Imagine a spacecraft no bigger than a postage stamp, a star chip, carrying a camera, sensors, and a communication system. Attach it to an ultra-thin light sail. Then from Earth, fire a gigantic laser array at that sail. Photons, particles of light, would push the sail and accelerate the tiny craft to a staggering 20% the speed of light. At that speed, the journey to Proxima Centauri would take roughly 20 years. 20 years in a human lifetime. Our machines could cross the void between stars in a human lifetime. Of course, the engineering challenges are substantial. You'd need to build a laser array more powerful than anything that's ever existed. The tiny spacecraft would need to survive interstellar dust hitting it at 20% the speed of light, which at that velocity is like being bombarded by tiny nuclear impacts. And communication? Sending a signal back from 4 light years away means waiting over 4 years for a reply. But the physics? The physics works. There's nothing in the laws of nature that says this is impossible. It is simply incredibly, almost unimaginably, difficult. Let's say we do it. Let's say 30 years from now, a tiny star chip screams past Proxima B at 20% the speed of light. It can't stop, it just flies by, and in those few hours of closest approach, it snaps images and takes readings. And beams them back across 4 light years of empty space. 4 years later, the data arrives on Earth. What might we see? Best case? Oceans, continents, an atmosphere with oxygen or methane signatures, chemical fingerprints of biological processes. Life, the first confirmed evidence that we are not alone. The reverberations of that moment would shake every religion, every philosophy, every assumption about our place in the universe. Everything humans have ever believed about ourselves would need to be reconsidered. Worst case? A scorched, airless rock. A cautionary tale about how even the most promising worlds can be made uninhabitable by a hostile star. And that answer would matter too. Because understanding the conditions that destroy habitability helps us understand the conditions that allow it. Including here, on the one planet we know for certain carries life, most likely, we'd find something in between. Something strange and unfamiliar that doesn't fit neatly into either outcome. Something that asks more questions than it answers. Because that's how science actually works. You might be wondering, why bother? Why pour energy and resources into a mission that will take decades, cost billions, and might only fly past its destination? Here's the thing. Every great human journey has started with the question, what's out there? Humanity has always moved toward the horizon, even when the horizon looked terrifying. We crossed oceans in wooden boats. We flew before we fully understood why flying worked. We went to the moon with computers less powerful than the phone in your pocket. Proxima Centauri B represents the next horizon. The first exoplanet we might one day, in some distant transformed version of our civilization, actually visit. Actually study up close. Perhaps, in centuries or millennia from now, actually set foot on. And even before we send anything there, just looking at it teaches us something profound. There is a planet right next door in cosmic terms that might be capable of supporting life. If the universe placed one potentially habitable world within walking distance of us, then the galaxy, with its 400 billion stars, almost certainly contains billions more. We might not be alone. We probably aren't alone. And that star, that small, dim, violent, ancient red star, sitting just 4.24 light years away, has been there for billions of years, watching us, waiting to be found. Proxima Centauri B is not a guaranteed paradise. It might be a dead world. It might be hostile beyond imagination, but it might not be. And in the vastness of a universe that doesn't care whether we ask questions or not, the fact that we're asking them at all is kind of the whole point. The stars aren't moving closer, but we are.